How's it going, everyone? Welcome. There again, looking at the advanced Redux, but because this particular course, which is taught by Steve Kinney, and as a way to understand now what Redux is doing behind the scenes, so we can have now that gut feeling and also the hands-on approach of how can we create Redux. So, despite the theory that Redux is involved, okay, it's important to now have a hands-on approach of how the things works. So that's the reason why we take a quick segue here with this quick recap about Redux. So we understand now what are the problems that this Redux tool actually solves, which is handling is the state in our applications, in clients or server-side applications. So this is a library that is not exclusively to React. In fact, that's the whole point of the entire library, is that it is agnostic, it is written in JavaScript. So as long as you have an application that runs on any of these JavaScript environments, the browser or the node, you can now use this state management, where the goal of this, right, is according to the maintainer of Redux, which is the town Mark. He described that in this particular very interesting blog, all right, about the idiomatic Redux, which is you can use is now Redux is in any language, but because this particular library was written in JavaScript, that's why I mentioned what I did. That's what I said what I did before. Okay, so as a way to recap, what are the goals and the intent, as well as the design. What is the design principles and goal? All right, as well as or the influence. So what is the influence and the goals, as well as the design principle and intent? So we can now get our look at what Redux offered to us, what it's doing behind the scenes, and then how now we can understand is what Redux is internally, all of this inner mechanism. And in today's video, we're gonna look at how can we create middlewares and recap some of these functional programming concepts, as well as how you can hooking up with React, which is not that. Again, the idea of this is it's important to understand how the thing is hooking up with React completely, but that's not what we really care about. So in any case, because the Redux, according to Mark blog, right? So because the Redux inspirations and influence and the goals is to now make the state mutations predictable by using the flux architecture pattern, where if we want to make now this state mutations maintainable and easy to visualize and test, we need to therefore use or set up some sort of constraint, immutability and serializability, which is now concept from functional programming. As well as we need to separate is the state update logic asynchronous, because Redux wants to all the state update to be synchronous, all right? And if you need to any asynchronous behavior, whether it's something that comes from the server or you are an input that comes from the server or a computer, right? Let's say the server or image loading or any human input, okay, that is asynchronous. So for example, waiting for the user to type or click or scroll, you know, whether of these asynchronous behaviors then we need to handle that separately, especially if this asynchronous behavior wants to update the state. So we're gonna keep them away from updating the state. So this is a notion that perhaps I don't have that fixed in my mind, because I don't know how the things work, which is something that we're gonna look. And so once we have now all of this update logic separate, and also if you want to now update that state, instead of having several states different, Redux, which is part of the influence from Flux architecture, Redux say, hey, let's going to now add all of this state into one single store, right? So we can now make things like persist the state or debugging much more easy, as well as if we want to now compose all of this update state logic, all right, we're gonna append that into a root reducer, where we're going to explicitly tell what are the data that we want, or the state that we want to update. So because of that, the intent of Redux is to get this influence from the Flux architecture. Okay, that's one of the things that we're gonna take a look at here on this Redux API quickly, right? So take influence from the Flux architecture, make the state update maintainable as a top priority, and when you need to do that, you must create your actions in a semantic and meaningful way. So by doing that, we need to rely on these functional programming principles. When you need to actually update the state management, we will now start to explore all of this particularly functional programming concepts, where one of the things of functional programming is that try to identify when a bug will happen and avoid it by applying patterns where they can never exist. So this is quite interesting. It's very, 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 very interesting, because this is when you started to see concepts like purity and immutability, as well as currying, right? Something that we're going to talk later. But the purity, what it means is that given the same input, you always return the same output. Again, this is to make our application and to functions easy to test. Similar to immutability. It doesn't mean that state doesn't change. It means that the state, in the context of software, we need to find a way to control needed change that need to occur with intent. So that's why we need this set of control mechanisms, especially as a way to prevent unexpected mutation to our state, to our data. That's why immutability means a layer of a control mechanism as a way to guarantee that change happens or needed change occur with intent. So the folks of Facebook actually create this particular tool called the Immutable.js. There are other libraries out there that, for example, that is using now is Imer, where this actually what it does is to create this control mechanism using proxy at runtime. And there are other libraries that is, instead of doing that at runtime, they create now at build time using TypeScript. So, but the idea remains. The idea here is that now that we have this set of mechanism, okay, as a way to know when the data change, similar, and this works similar as the git log, all right? So when on Git you store is the diff, and then you compare that with the previous one. Now this is pretty much what it's doing behind the scenes. Is like it's going to create now a new diff or an object with this new information, and internally pointing back to the previous one. So that's something interesting, especially immutability, serializability. This is much like how can we now make all of this data easy to access and currying. So with currying is something that we're going to talk about that in today's video. But the whole idea here is that to recognize this, currying and partial applications are just specialization techniques. In other words, both of them wants to now is to pass inputs or arguments, and then so giving a set of inputs, then you want to pass that to another function that takes that outcome and receive that argument, and do that over and over and over as a way to now get specialized outputs for that. So how does it work? How you can actually have a real life example of this? Well, for example, in an assembly line, on a motorcycle assembly line, where you have now the blueprints, and then from the blueprints they're going to now have another phase, which is the materials, and then on the materials, then is when you're going to now start with the frame, for example, right? And then once the frame is done, they paint the frame with the particular material that it needs to. Then you go to a next phase, which is actually putting the electrical systems, and then the brakes, and so on and so forth. Another good example is that when you go out and ask or buy an ice cream, right, with 3 flavors, right? Because the person it needs to do that one after the another. All right, let's say you ask for mocha, tiramisu, and lemon. You shouldn't mix that, but let's say you want that, right? So yeah, the seller is saying, okay, now let me take the Oreo or the banana split, and then the tiramisu. All right, so now that you have your ice cream almost complete, and then the lemon. So all of these different phases that is now adding to something, and then the return of that is the input of this net phase, or the next functions. This is pretty much what it's doing here, currying and partial application. So the subtle difference is that partial application, it takes a preset of inputs, and then let it on pass the rest of the prompts, or the rest of arguments. Where now in curry, it say, I'm not gonna receive anything first, but subsequent arguments, when calling this set of a function, I'm gonna get one input, one output, one input, one output, one input, one output. So why is that we need to use partial application, or this loosely currying? It's because it is convenient in the shape of the data that is returned. So this is just to describe at least 3 concepts of this. All right, and with this, because now functional programming provide all of these particular tools to make our code easy to test, as well as organize our tests by states, and data flow now is explicit, so we can actually understand what the data flow is. So this Redux now provides a minimal API that also is extensible, which is this small API, when you have now the compose, a very interesting function, as a way to now call this function, as a way to now call these particular functions from the input. So the input of a function, you pass now an input to a function, and then you return is that the output of that, and you're gonna pass that to the next function, and so on and so forth. In this case, it works by passing is the argument of the right, and then the output will be is the input of the left function, and so on and so on, right? So this is compose. We also look at create store, which is now actually make these objects where it now have the dispatch, the subscribers, as well as the state get state, and under the hood is using now something called as closure. So this closure, which is a JavaScript bonus feature it's a JavaScript bonus feature that allows you to know is a store persist the state of these applications, while also, or in this case, persist the state of the outer lexical scope, okay? And if you want to have access to that, you need to define a function to get into that. So this also provides now a layer of security. This is a pattern that CommonJS is now actually using. For example, the model pattern is actually using closures as well. But in any case, yes, we look at this create store. So you can see that I didn't lose my mind, right? This is this one. This is exactly what this object is creating. So dispatch, you get store, replace reducer, and subscribe. Okay, and well, we started to actually now creating our update logic, which is our reducers. First, we look at how can we create our dispatch action. As you can see, this is now a reducer, okay, and the reducer follow is this flux architecture, and how we need to define an action to trigger is a specific update logic inside of our reducer. How lengthy and verbose and error prone is that? Because anytime you actually create a new action in uppercase, sometimes you can misspell that, and those kind of errors are actually something that is easy to do. So that's why now instead of creating our actions like that, we have something called now the actions creator. So this actions creator, what it does is to, based on the flux actions pattern, we can now make a functions that make our life much more easy when it comes to create this particular action that is gonna update our logic. Gonna update the state logic. It's gonna update is our state. My bad. Now, that's great. Right, we also look at how can we set up the initial state. Usually if you're using Redux from scratch, it is better for you to set up that on the reducer level. You're gonna depend that, but the idea here is that it's easy to test that. And when you're now defining your reducer, this update state logic, it's important to follow certain rules as a way to now, as I mentioned before, make this state management, make this state update logic maintainable. So that's why we always returning is a new object. That's why we also following is the functional programming approach, which is purity, return always giving the same input, return the same output, make your object flat. All right, and all of this is just to understand why this reducer needs to return that particular new state, right? Because the idea here is that we have influence from the functional programming functional programming, they don't want to make assignment because that's something that can lead to error prompts. That's why they create these functions as a way to generate this new state out of that. We also look at the subscriber and binding actions creator. And subscriber, as I mentioned, suggests what it does is to say, hey, let's make this function be able to access to our state, right? So anytime this state changes, well, let's go to notify to all the functions that are subscribed about that change. So this is also following is the observer design pattern, where you have now the subjects and all the subscribers that wants to actually know what's going on with them. A good example of that is when you want to know some updates from Messi, Cristiano, or Messi, Cristiano, the politics, or I don't remember the name of, oh my god, the name of Jesus, the name of that pop star, Taylor Swift. That's right, Taylor Swift. Or you want to know is update about is LeBron, that kind of thing. So that's interesting. It's very, very, very interesting. And then we look at how we can now use this binding actions creator, which is part of the API. Remember, we got is this. Okay, we got is the create store, we got the compose. Let's go to take a look now the bind actions creator as well as combine reducer. So bind actions creator, what it does behind the scene is to say, hey, this is the action that I'm receiving, okay? And then let me now attach that to a dispatch. So instead of you having to call that dispatch with the particular reactions any time you need to, so let's go now is actually call that action when you need to dispatch. That's what is called this bind actions creator. So internally what it's doing is to, hey, I'm going to pass this actions creator, okay, which is functions that return is this actions of how you going in what is the type of update state, what is the type of update logic you want to do, and once you pass to that bind creator actions, all of these actions functions, internally what it's going to do is to now call this function that you pass and compose that with the dispatch, which means that when you compose that using the compose, you say, hey, let me call the, as you can see here in this example, okay, so let me now call this function, and whatever it returned, I'm going to pass that as the arguments to the function of the left. In this case, the store dispatch. And I'm going to call it, and I'm going to now is allow you and expose this particularly actions. So that's quite interesting. See, if we take a look at this example here, right? So we don't actually need to call the store. What is I think is this. We don't actually need to call the store, okay, like so, right? We're just only going to run that particular function, as you can see, right, in these actions. So given this particular bind actions creator, it's going to return this object that will have now is all of these actions that we can perform, right? So this is quite interesting. So then we look at now the combine reducer, which is another part of this API, and as their name suggests, it's pretty easy It's pretty straightforward. It's like what it's doing is that because you're going to pass all of these update logic states, okay, and this update logic are going to now because all of these reducers are you want to handle is one particular state, okay, and then you need to combine all of these update logics into this single store, right? That's pretty much what is doing this particularly combined reducer. It's also assigning is that, hey, this is the state that this update logic takes care. This is the state that this update logic takes care, and you're gonna pass that as an object. So this reducer, this update logic is the reducer, okay, and so on and so forth. And then you're gonna pass this reducer. Why this is important? Because this is not only is helpful when it comes to test your update logic, your reducer, and it make easy to read, easy to debug, and easy to test. So far we have looked almost quite enough of the surface of Redux, okay? And now we look at the enhancers, which is a very interesting concept here, because this enhancer, which is pretty much like a middleware, the enhancer here is now a curry function. What does it mean? Is something that I mentioned before. Is this function that is going to now receive some inputs, create some sort of a structure, do some sort of steps, and then return now a function with this specific inputs for this specialized thing that you want to do. So in other words, this curry function, what it does is to receive the inputs, apply some set of instruction, let's say transformation, some sort of logic inside of that, and then return is a new state or a new specialized functions here. So this is pretty much what we did here with this curry, and we need to actually understand what is the subtle difference between the partial application and currying. Both of them are specialization techniques when you're writing your application. And the specialization techniques, which means that you want is to now a set of or a particular shape of data, right? So that's why in our particular case here, when you take a look now at this, in this Middleware, right? In this Middleware here, it's like, hey, I just want to receive these functions. See, as you can see, this is actually a curry function, right? So a curry function, or a function that now takes a particular argument, apply certain instructions to return now a new specialized functions or shape or objects. So the whole point of this is to now make all of these functions that you need to, or all of this specialized function that you need to, and apply something on top of that. Pretty much like a phase of is like an assembly line. Okay, so in the example of the ice cream is that, hey, I want now that when you serve me these 3 portions of ice cream in the tiramisu, I want you to now add something on top of that, right? Of course, I'm gonna pay for that, right? But I want you to now add me something on top of that. It's like, hey, give me some sparkling, some chocolate, right? And then on the tiramisu, don't do that. And then on the lemon, spark some chocolate more. The whole point of this is that you're going to have these things specialized, customized for you. And that's exactly what we did here. When we are now creating is this one. right? When we are now creating is this one. So here what we're saying is that because we want to create now an enhancer, this query function, this thing that I want you to do on top of that, all right? This set of instruction that I want to actually to do something. In this case, monitoring is the performance. So I need you to give me is the all the necessary inputs, because this is also something, as you can see, is now a pure function. It doesn't take the state out of that, outside of these arguments. It just take from there. So take the create store, and now that create store, this is something that it can be quite confusing here. But the idea here is that you're gonna take that store, and then you're gonna return is a function, okay, that is going to receive now is the argument from the store. Again, all of this is something that is handling internally by the create store, all right, as you can see here, the create store. You got it. It say, hey, the enhancer. The enhancer is now this thing called store enhancer, and the store enhancer is either an object and the state like this. So store extension that is mixed in the store type, and the state extension that is mixed in the state type. Okay. So what I'm gonna do is that this particular type that I'm going to generate, which is the next, okay, which is store enhancer, store creator, all right. It say, hey, this next theme that I'm receiving, which is this store enhancer, right, is in fact is the state and the action, right? Is in fact is the state and the action that I can receive is the reducer and the preload state. So which is pretty much what we did is here. They say, hey, I'm going to receive is the state, which is something like this. I'm going to receive is the state and the actions, right? So this is the reducer, the preload states, and that kind of thing, right? Which is the reducer and the state, as you can see. This can be quite confusing actually to read. Totally, absolutely. But the thing here is that this is gonna take this next thing, all right, where this type of this will be is either this store extension or an state extension, right? And that will contain is the state and the actions for that. So, but in any case, the whole point of this, because this is the store enhancer, okay? A store enhancer is a high order function, and high order function is another functional concept. So this high order function, which is a function that takes is it takes a set of instructions as inputs, or it can return a set of instructions as an output, or it can be or it can do both, right? And by a mean set of instructions, it takes a function of that. So a function that composes a create store and returns a new enhanced store creator. This is similar to Middleware, that it allows you to alter the store interface in a composable way. Store enhancers are much the same concept of high order components in React, which are also occasionally called components enhancer, because a store is not an instance, but rather because a store is not an instance, but rather a plain object collections of functions. Exactly. You remember from this. It's not is a single object that is returning is this. So store is just a single object here, like that. But writing a plain object collections of functions, copies can be easily created and modified without mutating the original state. Copies can be easily created and modified without mutating the original store. So there is an example of compose documentation demonstrating that. Most likely, and why do you want to actually create a new copy of that? That will be a valid question. Well, because at the end of the day, you don't want to mutate the state because you're taking influence from the functional programming, where when you mutate the state, it can lead you to a lot of error out there. Therefore, creating is a new state with this new set of inputs is a much better, easier to maintain and test application. However, yes, it comes with a trade-off because you are now creating all of these copies of the object for that. That's why we have now immutable data structures as a way to prevent these cloning objects and have all of these objects copy in our memory. You can think of that as your own drawer, all right? So have all of this having all of these copies of your own drawer with different things or with customized things. For example, you have a drawer with a lot of socks, so you have 10 socks in that small drawer, where now the only thing that changed is the tonality of the black, right? Because you like this more like black and that kind of thing. The idea here is that to prevent this kind of unnecessary copy, we have now this particularly immutable data structure. So, but in any case, again, as I mentioned before, what is immutable data structure? But here we are, all right? So most likely you will never write a store enhancer, but you may use the provider by the developer tool. It is what makes time travel possible without the app being aware is happening. Amusingly, the Redux Middleware implementation is itself a store enhancer. So now that we look at this, all right, and how can we now implement our own enhancer, which is part of the Redux API. Let me actually put it here, Redux API. No, Redux API. Exactly, Redux API, right? Create store and the enhancer, right? Which is this, the enhancer, all right? Which is a query function. Now that we know what are the powerful things that we can do with this enhancer, which is adding functionality of this store or this object, okay, this plain object, because at the end of the day, Redux is just a plain object with functions attached to this. We can now check or do something when these particular functions are executed or called, right? And that's why in our case, okay, which is here, what we did is just to, for example, measure how long it will take an action to dispatch, okay, or a reducer or a particular update logic to update, right? And the other is a logger, is that what are the actions here that are getting triggered and what is the previous state and the current state. This is something interesting because, as you can see here, it's starting to build up the notion of how this Redux DevTool actually works behind the scenes, right? By using now this concept of the enhancers, you can now is put some logic before the store is running, okay? And anytime the function is running, this particular enhancer will be called, right? As a way to now is, hey, I want to now add some functionality to this. I want to now I want to add a functionality that allow me to see is what is the previous state before updating, before calling the update logic, okay? And then give me is a new state followed by the actions, or measuring is the performance when you're calling your reducer. Again, very, very, very interesting stuff. Why is that? Because this will unlock the powers of Redux Dev Toolkits. Oh my god. Interesting. So what is the subtle difference between an enhancer and a middleware? That's a very, very, very interesting question. Okay. So is that store enhancers are high order functions. This particular concept. Okay, high order functions are interesting. It is what makes the time travel possible without the app being aware of it is happening. Amusingly, the Redux Middleware implementation is itself a store enhancer. So what is the subtle difference between a middleware and enhancer here? That's a good question. What about, let's going to ask that to Claude. Okay. So what is the difference between a middleware and an enhancer in Redux? Okay. So Redux is the enhancer is a high order function, and the middleware is a function that intersects something. Exactly. So middleware intercept actions to add behavior between dispatch and reducer. Okay. An enhancer modified the store, modified the object itself by adding or changing core functionalities. Okay, this is the subtle difference between an enhancer and the middleware in the context of this, right? Okay, enhancer exercise makes a lot of sense. And here we can say is, let's actually take a look at the middleware example, right? Let's go take a look at the middleware example.
Enhancers are kind of useful if you want to change the overall implementation of your store. We have not looked at the Redux DevTools yet, but I'll give you a little bit of a... So that's enhancers. And as I kind of alluded to before when we were asking and answering questions, was apply middleware creates one enhancer out of a series of a chain of middleware. One of the useful ways to think about this is enhancers are kind of useful if you want to change the overall implementation of your store. We have not looked at the Redux DevTools yet, but I'll give you a little bit of a sneak peek, which is it has a whole bunch of things like the ability to load in state through the DevTools, export the state from the DevTools, dispatch actions, undo and redo, and all these features. So it's adding a lot of functionality to Redux, and so it's definitely going to use an enhancer. However, if it's something like, I just want to like modify actions as they come through because I want to do async things, I want to log them. Like we use middleware, for instance, we use middleware to log customer behavior to like segment or something along those lines. So like, oh, they're firing these actions, like they're visiting this page, we'll log that to segment or Datadog or what have you. So you want to say as actions flow through, I want to do something. Middleware is a really, really great way to modify how dispatching actions works in your application. And effectively, this is an abstraction over an enhancer, but just a way for just managing actions as they flow through. And apply middleware allows you out of the box to compose an entire chain of middleware. Let's go ahead and we'll kind of look at how that might work for us. So let's go ahead. We'll get rid of these for now. Actually, we'll keep them because we're gonna use them for parts.
Why is the enhancer passed through the enhancer again?
Why is the enhancer passed through the enhancer again? Oh, because if you want, for example, pass now this another set of instructions or enhancers, all right? You want is to actually is stacking all of this enhancers. You want to actually stacking all of this functionalities that is applied to the store, right?
So you're matching the same API. My gut says, I was thinking about this earlier, my gut says it's probably memoizing, which is if you got the same enhancer as last time, we're not passing it through again, right? So we're trying to, like, if we get the same enhancer, don't pass it through each time, but you want to make sure you're following the same API, because you could theoretically modify the enhancer and replace it as well. If you want me to come up with a hypothetical use case for why you would ever want to do that, I can make sure you memoize.
Through the enhancer again?
So you're matching the same API. My gut says, I was thinking about this earlier, my gut says it's probably memoizing, which is if you got the same enhancer as last time, we're not passing it through again, right? So we're trying to, like, if we get the same enhancer, don't pass it through each time, but you want to make sure you're following the same API, because you could theoretically modify the enhancer and replace it as well. If you want me to come.
So, well, if you imagine that this is now the way of how you can pass this set of instructions, this set of enhancers to your new specialized functions, or this new ability that this application can do, the idea perhaps by passing now that enhancer is that you want to somehow to memorize that, right? And by memorizing that, so you just only now have that same reference on your memory, and then you only call that as it is.
Come up with a hypothetical use case for why you would ever want to do that, I cannot. But it is there to do if you needed to do it. But yeah, I think your gut of like, I shouldn't do that is probably a good spiritual thing to listen to. All right, so middleware has just got a slightly different syntax. So we'll go ahead and we'll say something like, let's make this one, I will make the log. Middleware is a really, really great way to modify how dispatching actions works in your application.
So enhancers modify the store itself and changing its core functionality, right? Composing function is in compose. Enhancer runs when creating the store. An enhancer has the entire store creation process. Exactly. So enhancers, okay. So enhancer is a query function. So enhancers modify, exactly. Enhancers modify the store itself. Remember, it is a plain object. Okay, it is a plain object, right? So remember, it is a plain object. Here, modify the store itself. Remember, it is a plain object with functions attached to it. All right. So by adding, exactly. So by adding or changing, it is core functionality. So in no particular case, in no particular example, enhancer is a query function. Okay, what is a query function? With a specialized input. So a enhancer. Okay, so what is an enhancer? Okay, is that right? So what is an enhancer? So what is an enhancer? Is a function. Okay, so a function that modify the store, which is a plain object with functions attached to it, right? The dispatch, subscriber, get state, that modify, that add or modify or change it is core functionality. So for example, exactly, it is core functionality. It is called initially, okay, intercept actions add behavior between the dispatch and but it is runs when creating the store. It is run when creating the store, right? It has access to the entire store creation process, which mean it has access to the entire creation process. So then we look at the example here. All right, and then this is the exercise example, like that. The index here, that's right. Enhancer exercise, there you got it. And then Middlewares. But Middlewares here intercept actions to add behaviors between dispatch and reducers. Interesting. So Middleware, exactly, because after all, a middleware is a piece of software that intercepts something. So that intercepts something to add or remove out of it. So enhancers is something that now extends or changes the core functionality, whereas middleware is something that is interchange something and then return out of that. Intercept something to add or change and then return something. This is, that's one of the reasons we need to actually clarify is the that's what we need to clarify is the definition of concepts completely, man. We need to clarify is concept definitions. Absolutely. Absolutely. So okay, enhancers. So in Middlewares. So interception. Intercept. This is intercept an action when this is patched. Okay. Intercept actions. Okay. Intercept actions to add behavior between dispatch and reducer. Intercept actions to add behavior. If you remember what an action is and how you can create an actions here. So intercept actions, which is this will indicate what is the update logic that it needs to run. Okay, intercept actions to add behavior. To add behavior. To add behavior between dispatch and reducer. Between dispatch, hey, this is the action that is going to be dispatched, and this is the logic that I'm going to, this is the update state logic that I'm going to run based on this action. Okay, so change together using apply middleware. It changed together with apply middleware. Why do we want to actually intersect actions? When we want to intersect actions between the dispatch and the reducer, these actions, okay, perhaps when we run this action, perhaps when we intercept these actions, we want to do something, okay, So before updating before dispatching these actions, we want to do something here. Makes a lot of sense. Makes a lot of sense. What you want to do is, for example, is hey, I'm dispatching these actions, or sending an error logging from that. Jesus.
And effectively, it is an abstraction over an enhancer, but just a way for just managing actions as they flow through. And apply middleware allows you out of the box to compose an entire chain of middleware. Let's go ahead and we'll kind of look at how that might work for us. So let's go ahead. We'll get rid of these for now. We're going to use an enhancer. However, if it's something like I just want to like modify actions as they come through because I want to do async thing.
Exactly. You just want to modify actions that are coming through. Runs when creating runs during dispatch process. Interesting. And in this case, it's a function as well. Okay. And in this case, a function that intercept actions to add behaviors between dispatch and reducer. It chains together with apply middleware, and it runs during the dispatch process. It runs during the dispatch function or the dispatch process. So, for example, you want to change an action that is passing through, or
I want to log them. Like we use middleware, for instance. We use middleware to log customer behavior to like.
So use case of middleware is that log customer behavior.
Like segment or something along those lines. So like, oh, they're firing these actions, like they're visiting this page. We'll log that to segment or Datadog.
Okay. Log customer behaviors based on page navigation. Log customer behavior based on page navigation and then send it to a Datadog or Sentry. Any of this. Okay, Sentry. The only application monitoring platform. Exactly. Error monitoring, season replay, code coverage, and tracing. Datadog or Sentry. Exactly. Monitoring tools, bro. Monitoring tools.
Or what have you. So you want to say, as actions flow through, I want to do something. Middleware is a really, really great way to modify how dispatching actions works in your application. And effectively, it is an abstraction over an enhancer, but just a way for just managing actions as they flow through. And apply middleware allows you out of the box to compose an entire chain of middleware. Let's go ahead and we'll kind of look at we'll look at how that might work for us. So let's go ahead. We'll get rid of these for now. Actually, we'll keep them because we're gonna use them for parts.
Why is the enhancer passed through the enhancer again?
So you're matching the same API. My gut says, I was thinking about this earlier, my gut says it's probably memoizing, which is if you got the same enhancer as last time, we're not passing it through again, right? So we're trying to, like, if we get the same enhancer, don't pass it through each time, but you want to make sure you're following the same API, because you could theoretically modify the enhancer and replace it as well. If you want me to come up with a hypothetical use case for why you would ever want to do that, I cannot. But it is there to do if you needed to do it. But yeah, I think your gut of like, I should hypothetical use case for why you would ever want to do that, I cannot. Following the same API, because you could theoretically modify the enhancer and replace it as well. If you want me to come up with a hypothetical use case for why you would ever want to do that, I cannot. But it is there to do if you needed to do it. But yeah, I think your gut of like, I shouldn't do that is probably a good spiritual thing to listen to. All right, so middleware has just got a slightly different syntax. So we'll go ahead and we'll say something like, let's make this one, I will make the log middleware and you can make the enhancer this time. So I'll say, we'll make some log middleware. And middleware is much more common. Like I said, we use it for logging actions to our different data reporting tools.
So log middleware, what it's going to trigger is on every dispatch process, which is every time you want to now is run this update logic. It's like, hey, I want you to now is run this update logic based on these actions. Okay.
You can use it for all sorts of different things as well. But let's see, this is more likely that you will almost never write an enhancer, and you will absolutely, maybe, possibly, with a chance, write some middleware. Like we definitely have. So it takes a bunch of curried functions because things get passed in at different times. So we can say store, next, and action, which the store is the actual store that we
okay. This is interesting because it's also a curried function,
right? Next.
So if we take a look now at the Middleware, no. Apply Middleware, right? We take a look now at this. Take me to the apply Middleware, where all of these are. This is a middleware. Okay, middleware type. But you have now the dispatch. Okay, extra dispatch signature added by this. A middleware is a high-order function that composes a dispatch functions to return a new dispatch function. So in other words, this dispatch function, which is going to call now is this particular logic. Okay, this particular update logic. When you apply now a middleware, you are now intersecting this dispatch process to do something else with that. Our main use case of this is that you want to now log the customer behavior. So in other words, it's that when the user now navigate to a particular path, you want to send that to some analytics tools or monitoring tools. Let's say Datadog or okay. Let's say Datadog and that kind of thing. Sentry as well. Middleware is a composable. It is composable. Exactly, using functions composition. It is useful for logging actions, performing side effects like routing. Interesting. Logging actions. Okay. Log customer behavior. Logging actions. Logging actions perform side effects like routing. Performing side effects like routing. Okay. Or turning an asynchronous API call into a series of synchronous actions. Interesting. Turning an asynchronous API call, turning an asynchronous API calls into synchronous updates, into a series of synchronous actions, into a series of synchronous asynchronous action. What does it mean here is that remember that at the core of the goal and the influence of Redux is that make all of the state updates synchronous. If you need any async behavior, keep that away from the act of updating, which is exactly what you're doing here with this now actions, with this middleware, with this intersection of the action process, of the dispatch process. Hey, you want to now actually log the user navigation page? Good. You want to logging actions? Good. Do you want to now is based on a particular actions turn all of your async operations, okay, whether it's routing or also is the API as well, the API calls, which is something that you have to wait for that. Once you wait for all of this, then you're going to now transform all of these asynchronous operations into synchronous actions, into now actions that is going to update the state logic or the state of our applications synchronous. Is here when you add in your asynchronous behavior. Makes a lot of sense.
Next is actually dispatch, because each piece of middleware will call the next piece of middleware, kind of to the question I just received, right, where you can call.
Interesting. As you can see, it now takes is the S, D, the dispatch S and D. All right. So it's now generating a new interface. Okay. With this shape, that this interface will have now the API, middleware, DNS, and the. So you're gonna take the API here. Okay. That also now calls. Okay, so the API here, which is a function, is now a function with the next dispatch that will return is these actions here. Holy moly, bro. All right. Apply middleware. So middleware is a suggested way to extend Redux with custom functionality. Middlewares let you wrap the store dispatch method for fun and profits. The key features of middleware is that it's composable. Multiple middleware can be combined together where each middleware requires no knowledge of what's come before or after the change. The most common use case for middleware is to support asynchronous actions without much boilerplate code or dependency on the library like Rx. It does not let you dispatch asynchronous action. Okay, it just lets you this exactly. It does so by letting you dispatch asynchronous actions in addition to normal actions. So for example, Redux thunk lets the actions creator invert control by dispatching function. Invert control. What in the F is this? Here we go. So let's actions creator invert control by dispatching functions. They will receive dispatch as an argument and may call it asynchronous. Such functions are called thunks. And thunks, which is they will receive dispatch as an argument and may call it may call it asynchronous, which means that such functions are called thunks. And a thunk is just a term that predates JavaScript, where you are one which is a wrapper around, is a time independent wrapper around a value, which is now the fundamentals of the promise. Because you don't know You don't care when this will happen. I just only care that you get me the data when that is available. Another example of middleware is Redux promise. It lets you dispatch a promise async action and dispatch a normal action when the promise is resolved. Interesting. The original Redux create store method does not understand what middleware are out of the box. It has to be configured with apply middleware to add that behavior. However, Redux Toolkit configures store method automatically add middleware support by default. So now you have the customer logger middleware as well as the using thunk middleware for async actions. Make a sandwich with secret sauce, which is a function that at some point is going to now get you what you need. Sandwich props dispatch for person, and then you connect with that store. So apply middleware. Okay, another example of middleware is Redux. Oh my god. Okay. So async action. This is middleware. Type middleware API, which is now this, and then receive the next to actually dispatch. So you're gonna get the API, which is middleware API, the store, the next, and the action. The API, middleware API. And when they talk about middleware API, okay, extends from the dispatch. Okay, and the state. So you get now is okay. You can quite assume. No, that's not assume. You're gonna get is the dispatch and the state. It's not the store, by the way. What you're gonna get is the dispatch and the state from that. Okay, followed by that. Holy moly, bro. The whole point of this is to understand all of these concepts and then how you can apply to your real life problems. That's all, bro. That's why we are doing this. That's why we are doing this. Holy moly.
The next one in an array of middleware. Finally, when you get to the end of the array, then you're dispatching to the reducer. And the cool thing about middleware is that, like the enhancers that we just wrote, it gives you the opportunity to do a bunch of things before you hit the reducer, and then also again after it leaves the reducer. So you get to like insert yourselves at both places.
Exactly. During the dispatch process, which means is that before the reducer and after the reducer.
There as well. So with the log middleware, we'll simply say something along the lines of, and you'll see that the syntax is a little bit cleaner. So we'll say something like console log, and we'll say
the old state here.
And we'll say store.getState.
With the store.getState, that's right.
And I mean, we could log the action too.
And the action, exactly, that you are actually getting here.
Pull that down here, and we're actually one of the comments we got before is like, oh, we want to call with the new state. This time, since we're just using the store, it's very much before. We can call store.getState, and it will be the current state at that moment. Exactly. We'll say new state, and here we'll say.
You're gonna call next,
and give it the actual action, so it flows through. Right. So now we can pass it in there as an enhancer, but it's middleware, so we just have to use this apply middleware. Cool, and you can see old state, and we're not really modifying the state here, but you can see it each time. We've got an old state and new state beforehand. So this is Everything happens before you pass it through the rest of the middleware and eventually the reducer, and then you get access to it again after it's left all of the middleware and the reducer. So it's a cleaner and simpler syntax for writing those enhancers, so you don't have to make a whole bunch of enhancers, compose them. If you're just trying to intercept actions, this is super useful. The most famous, let's go with it. The most famous use case for middleware is a library that is used in Redux Toolkit and very commonly in Redux applications called Redux thunk. Let's go with it. The most famous use case for middleware is a library.
Okay. 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 The most famous use case of middleware. The most famous use case of middleware is Redux-RTX. God damn.
That is used in Redux Toolkit and very commonly in Redux applications called Redux thunk.
And very commonly in Redux application called Redux thunk. And in Redux application, in Redux applications called, and in Redux apps, Redux thunk. And I get it why they're using is that, because they don't want to overcomplicate that. They just only sending the state on each one of them. They don't overcomplicate their life with that. They're not overcomplicated.
How is this website, which is 100 years old, it's not 100 years old, but it's a 100-year-old company.
MacMaster. $100 old, bro. Damn. Something that is using is not only Redux, but is Redux. Exactly. Holy fuck. They have inherited Allah. And they're using jQuery, migrate, and Dewey underscore. Man, as long as this shit works, If we're gonna go back, that's right. Oh, but they're doing is that oh shit, I think they have to stop that because there was a spike in that network. Yeah, I think I think they have to stop that. Yeah, I think they have to stop that. They have to disable that. God damn it, bro. Okay, Jesus. French toast guy. Okay.
How would they have the fastest website on the internet? That's a tweet from Kenneth Castle last night. and oh, good old HTML is nice and fast, but that's not the case. Is I believe that the engineers behind McMaster-Carr's website are doing everything possible to make this website as fast as they possibly can, and they are using all of the tricks in the book. So let's dig into how I figured that. It's simply the server returns HTML, and the browser is very good at rendering out HTML. Now, they are also prefetching HTML. So watch, when I clear this out and I hover over some of these links here, you'll notice that my network is going crazy. And if you click on one of those, you'll see that it is returning HTML
exactly. Now they
the
disabled
URL
it.
changes. And what's happening there is they are simply just taking this HTML, swapping out they call it a shell. I understood from viewing source. They're just replacing the part of the website that does change, and things like the nav and your order, maybe your shopping cart. Those things don't change from page to page. So obviously they change that. That's not new. We've been doing that for a long time with push state. However, they are doing that so it feels nice and snappy. So between pre-rendering it, pre-downloading it, and then using push state to put it on. Now, they are also using caching pretty aggressively. So if we take a look at the headers of one of these requests, you can often see something like these headers here that will tell you if it's been cached or not. This one looks like it was not cached, but you're often going to see something like hit or miss in here. And then
okay, that's quite interesting. That's quite interesting. So makes a
There it is now. So let's say hypothetically you needed to make a AJAX request or a fetch HTTP request. You could dispatch an action, but actions aren't valid. So what could happen was like you get the action here, then you fire the promise or the AJAX request, and then you fire a real action afterwards, right? And that is kind of, normally we use a library called Redux thunk, but that is effectively how it works. It's just type checking, like if type of action is actually a function, call the function and pass it dispatch, and allow it to then figure out what to do and pass it through.
Exactly, call this function that now allow us to make this.
You fire the promise or the AJAX request, and then you fire a real action afterwards. Right?
Exactly. So you call the, but that's the
so let's say hypothetically you needed to make a AJAX request or a fetch HTTP request. You could dispatch an action, but actions aren't valid. So what could happen was like you get the action here, then you fire the promise.
Exactly. So you intersect the actions. This is one of the most widely common use case is that you dispatch the actions, then you now exactly. You dispatch the actions, then you now perform some of async operations, make a promise here or a thunk here. Then once you get the data, now you is return that value to update that state.
Or the AJAX request, and then you fire a real action afterwards, right? And that is.
Then you fire the real action afterwards.
This kind of, normally we use a library called Redux thunk here, then you get AJAX request or a toolkit, and very commonly in Redux applications called Redux thunk. So let's say hypothetically you needed to make a AJAX request or a fetch HTTP report.
Okay. So let's say you need to hypothetically run an HTTP request, right?
In Redux applications called Redux thunk. So let's say hypothetically you needed to.
Okay, let's say you need to hypothetically make an AJAX request or HTTP fetch, right?
Make a AJAX request or a fetch HTTP request.
Or fetch HTTP request, right?
You could dispatch an action, but actions aren't valid. So
exactly, you could dispatch an action, but actions are not valid. Hence,
what could happen was like you get the action here, then you.
So by using a middleware, you can intercept that action. Exactly, by using a middleware, you can intercept that actions, perform the HTTP request, then fire the promise. So fire the promise. go exactly. So intersect the actions, they fire the promise, and then
you fire the promise or the AJAX request, and then you fire.
So fire the promise or AJAX request, and then so intercept that actions, fire the promise or AJAX request, and then fire the real action afterwards.
Real action afterwards, right? And that is kind of, normally we use a library called Redux thunk, but that is effectively how it works. It's just type checking, like if type of act.
So usually that's how Redux thunk actually works.
Action is actually a function. Call the function and pass it dispatch, and allow it to then figure out what to do and pass it through the rest of it. So.
And the thing here is that this is not the example, right? But it's very specific for this particular stuff, right? It's very specific for this particular stuff, bro. This is you create an enhancer. So far so good, all right? But you want to create as a middleware for that. Store next and actions. Exactly, and they call store because after all it's a middleware API that is exposed is now the get states or the dispatch. Let's get into this. Okay, let's now define a middleware, and that is, let's say, hey, cons action middleware or log middleware, right? So log middleware of what are the actions that is happening here, right? So here you're gonna get the store, which is a middleware API that you get here first is the get state and the dispatch that now it actually returns another function that contain is the next, which is part of the middleware. And last but not least, you actually get is the action you're going to do. So you can see here what it's doing is now is this is another currying function, because what happened here is that a strict currying function, because one input you get a single output, single input, single output, single input, single output. And then you say, okay, I want you to now is log what happened here, bro. To the store dot get state, okay, get state, followed by the actions, okay. You can now here call the action, in this case is next, and the action by saying, hey, I want you to now run this action, okay. And once that is done, or you can define here your async logic, then you want is to now is look at that. So get state here and the actions as a way to distinguish one from another. You can say, hey, this is part of the middleware, right? So log middleware makes sense, right? Say log middleware, and here the same log middleware, right? So now when you save this, and then you want to add that to the log middleware, the store instead of doing this, instead of actually passing the composer enhancer here, right, you're going to now passes the apply middleware for that. Say apply middleware, and the list of middleware that you want to define that. So log middleware, for that. But it say, hey, log middleware is not defined, which means that you need to define that at the bottom, at the top, okay. And then you say log middleware, log middleware, that's it is. So this is funny because it's not hosting that. No. Then you say, hey, middleware is not a function. I don't know why you're still actually doing that. Thanks for that. And then you say, yes, you need to first define that so you can now have access to that as expected, right? Which is great. Now, when you take a look at what's going on, refresh that. You can actually see is that logging, it is triggering, it is detecting all of the dispatch that was triggered before and after. So again, the sort of difference between enhancer and the middleware is that enhancers now allow you to add or extend the core functionality of Redux, which is after all a plain JavaScript object with a series of functions attached to, but middlewares allow you to intersect actions when the dispatch function process is called. So in other words, this is something useful for logging your actions or knowing when your users are visiting a particular web page, for example, the routing, or something that is, I think this is the most popular thing that it's doing, is now perform these async operations. So you want to make an AJAX request or fetch HTTP. You add the middleware, so you can now intercept that actions, run the or fire the AJAX or HTTP request, and then you fire that. You fire the proper action. You fire that current action. And then you fire the real actions afterwards. Very interesting. So we can do this and create now a file called here middleware .gs. All right. All right, so that'll be all for this video. Take care. Bye bye.